So quick update again, now have the clock PCB directly driving the program counter PCB, as you can see here. We can do a number of things with this clock PCB. We can vary the rate, excuse me if I hold the PCB. So we're in high speed mode at the moment. If I switch it to low speed, we can go anywhere from 2 millihertz, so once every 9 minutes. That gives us about 1 hertz. And we can go all the way up to 62 hertz or 61 hertz, sorry. So that's pretty good. And we can go in high mode, and we can go all the way from 122 kilohertz, sorry, 122 hertz, which is around here, all the way up to there, which is 4 megahertz. The program counter is counting. I know you cannot see it, but trust me, it is actually counting up, so that's really good. You can pause, at which point program counter stops, and then you can single step. So if you're doing any debugging, that's a nice easy way of doing that. Put it back into low mode, and let's set it round to 1 hertz again. You can of course do a reset, just hold down the reset and the program counter resets on the next clock pulse. Everything's going okay. The brightness control does work, but I ran out of these parts, so it's not in there. But the brightness control controls the brightness of all the LEDs and these TIL311 chips. So yeah, it's all starting to come together finally. Another mod wire on here. That's because the reset on the program counter only resets when a clock pulse comes in, and the reset here before was resetting the main divide by 32 counter. So I've had to just leave that permanently running. Not a big deal, because all we get out of that is literally just the phase 1 clock, phase 0 clock. There is a delay here, a Dallas chip that gives me delay in increments of 50 nanoseconds up to 500. This gives us our second phase of the clock. So the idea is that the program is loaded on the first phase and executed on phase 2 or second phase. I'm hoping we can get down to 50 nanoseconds, which then means we can run at like 2 megahertz, 4 megahertz. The risk there is that the multiplier has a lot of logic gates on it, and the propagation delay may be longer than 50 nanoseconds. So that's fine. The project goal was to get to 1 megahertz or 1 MIPS, but it would be nice if I could get to 4. So I'm keeping my fingers crossed that we can get the gate delay to under 50 nanoseconds. That's everything. Thanks for watching.